All right, so this is lesson 3.2. It's on energy transference systems. So a man is riding his bike downhill. He starts to pick up speed. He needs to slow down before he crashes. He applies the brakes and slows down. After using his brakes, he noticed that they got very hot to touch. How can we explain this? How can we explain this? Well, if you think about it, heat that comes off of brakes is just energy. Okay, it's energy that came from somewhere else, and it has been transferred to the brakes. And how does that work? Well, if you look at a system, right? Systems are what hold energy. So a bike and a bike rider is a system, right? The Earth is a system, and a system is a really there's systems inside of systems, and systems can you know use the same objects in them. They could use the same energy. They could share energy, but a lot of times a system is what you choose to observe. And we have different kinds of systems. We have closed systems, we have open systems, and we even have isolated systems. If you were to look at everything around us, pretty much everything is an open system. And what that means is that energy can go from that system out of that system, and it also can be absorbed by that system. And matter can be uh, given out of that system to its surroundings, as well as absorbed from the surroundings back into the system. Most things are open systems. For instance, if I open up a can of soda, I have opened a closed system, which is not a perfectly closed system because the soda can change temperature. But if we were just to think this through here, when we open up a can of soda, what happens? Well, it bubbles. Why does it bubble? Well, it bubbles because the gas that was trapped in the soda that keeps it carbonated, carbon dioxide, is actually going to be expelled from the can, and it's going to be given off to the surroundings. That's why if you open up the can of soda, it's actually going to become lighter as it sits there and loses its carbonation. That's because some of the matter that was contained by the sugar and the water that holds the soda together is actually going to be lost once you open the can, because carbon dioxide naturally wants to be a gas at room temperature. So you have to keep it really cold. So that's it. That's an open system. Once you open the can, open system. Closed system might be when the can is closed. Open system could be your body, right? Um, we use energy all the time, right? Whenever we make, we eat food and we go on a run, that is energy being given off to my surroundings by energy transfer all the time. So we have closed systems and open systems, and this is just um, a general perspective of how it works. Most things are open system. A closed system really isn't practical in our daily life, but I'll define them for you. System which we can exchange energy with our surroundings is called a closed system, but whenever we can't exchange matter, that's a closed system as well. The opposite is true for an open system. We'll exchange matter, or we won't exchange matter, but we can exchange energy. Energy is really hard to keep within a system, and that's why we always think that energy is being lost all the time, but it's really just not being lost. It's not created. It's not lost. It's just often absorbed by our surroundings. So let me give you an example of an energy system. So here we have the sun shining. It's shining on a solar panel. And that solar panel is taking the radiant energy and converting it into electricity. And that electricity is being used by the light bulb. And the light bulb is giving off heat, and it is also giving off light. Those are also, so that's four forms of energy right there. Okay, light and radiant, radiant from the sun, light from the light bulb, they're not the same thing. But in this diagram, it kind of looks like it is. So anyways, we have energy flowing through a system here. And you could see that if we were to take the energy from the sun, we were to take the energy from the light bulb, so we have input and output there, we're not going to have the same amount of energy. And that's because the heat is being given off to the surroundings, and that is accountable for some of the energy that was being lost. So don't assume that the energy is being lost. A lot of times it's just being absorbed by the surroundings. So what does energy look like? So there's lots of different forms of energy, and we're going to get into that more and more and more and more. but it can be chemical potential energy, so the energy we store within our body that we use to do work. Let's say go on a run, play football, play sports, um, bite, whatever. I mean, we need energy for everything. Um, it can be gravitational potential energy, energy caused by the potential given from gravity. When we have a really high roller coaster, it wants to go down, and the higher you take that roller coaster up, the more capacity it has to do work and pull the rest of the roller coaster down. It could be stored within the bonds of propane, right? We have a propane tank there. That is a lot of energy being absorbed in a really fine, small place. So that is a form of chemical potential energy as well, right? This is mechanical energy if you're counting the work being done, and this is chemical potential energy. But we also have, chemical potential energy stored within our body. And then it could also be elastic potential energy. If I take a rubber band and I pull that rubber band apart, I'm giving it potential to then spring back, just like the spring operates off the same principle, elastic potential energy. We're going to look at all these a lot further, but those are, I said that funny, those are just a few of a lot of different types of energy. But the first thing we'll do is we'll look at the two broad categories, and that's potential energy and kinetic energy. Those are the most important two broad categories, and then we'll look at them a little bit more detailed later on. All right, guys, that's all I got for you today. We'll be at 3.3, conservation of energy, next time. Bye.